Hello. I would say good evening for all of you, and this is the third day of our practical video on the course of practical pharmaceutical analysis. So in the first two tutorial video, I'm sure that you have to get some pointers about standardization and estimation of the amount of active ingredient as well as the purity of aspirin. And today we try to cover the very interesting drug, which is an assay of ibuprofen. This is the third tutorial or the third practical session for our uh, courses for pharmaceutical analysis. So I'm sure you have to get very interesting concept from this practical video. So don't forget to subscribe the channel before going to the video. So let me start by subscribing the channels and link the share, copy link the share for your fellow friends, and you have to get what the hot video like this in consecutive days. So for this experiment we need what a chemicals and apparatus so as to follow what the procedure to get the right result from the estimation or the assay of ibuprofen here. So the most important apparatus or equipment that we require for this experiment is that beaker of different size, maybe beaker of 250 ml or 250 ml or 300 ml. It is no matter, but the beaker is very important. Conical flask with the medium size, especially 250 or 200 ml of conical flask is very important. Pipettes, whether Pasteur pipette or different type of pipette are there, so any pipette can be used for what sucking the different chemicals from the containers. And the burettes, very important equipment here is the glassware burette, which is used for titration. And you have to see on the thumbnail of the this video, burette is one that can be linked or used what filling the chemical for titration. And the measuring cylinder of different size can be used for weighing the volume of different liquid solvent. We have to use what this measuring cylinder, and the burette stand and the holder are used for what tightening your burette on the iron stand, and the glass funnel for using what inserting the chemicals, especially sodium hydroxide in the burettes. You have to use glass funnel. Actually you have to it is possible to use any funnel, plastic funnel also, but glass funnel is preferable. And the volumetric flask is used for preparing a solution, especially standard solution. And the spatula is using for taking the pellet of sodium hydroxide from the container to that of the weighing paper during measuring the weight or sample preparation. The chemical important for this experiment is that ibuprofen tablet, which is obtained from commercial drugstore, and 0.1 molarity of sodium hydroxide can be prepared, which can be previously standardized by the experiment. And the ethanol, which is a pure ethanol, almost 96% to that of 99%. Ethanol is again very important for this experiment. And the most important indicator here is also phenolphthalein, which can be used for what acid-base titration, and the phenolphthalein indicator also used for showing the end point of titration. Therefore, having this all apparatus and the chemical is very important, or the prerequisite for assay of ibuprofen. So when it comes to the theoretical concept of ibuprofen, as you see, ibuprofen have the molecular formula of C30H80O2 and with a molar mass of 206.3 0.285 gram per mole, and the density is approximately 1.03 gram per ml, and the melting point is a range between 75 to that of 78 degrees Celsius, and the boiling point is 153 degrees Celsius. And actually, since this drug have acidic functional group, it can be easily soluble in water because it is having what a polar nature. Do you know this ibuprofen is a medication in non-steroidal anti-inflammatory drug classes that is used for treating pain, fever, and inflammation. Therefore, it is the most important anti-inflammatory drug. And this drug includes migraine and rheumatoid arthritis, and it may also be used for loss of patent ductus arterius in the premature baby. And it can also be used, it can be also be taken either orally by mouth or intravenously, so it can be given in IV or orally, it can be given, and it can typically begin working with an hour. So, and the half-life of this drug is very short, so it can be what's very important to give what's very rapid pharmacological effects. So when you come to the other chemical which is important here is sodium hydroxide. Actually, you know that this sodium hydroxide is with a molecular formula of NaOH with molar mass approximately 40 gram per mole or 39.997 gram per mole. And its actual density is almost 2.13 gram per centimeter cube, and the boiling point is very high, around 1388 degrees Celsius, and it can be soluble easily in water, ethanol, or methanol because of the polarity nature. And this sodium hydroxide, also known as lye or caustic soda, and it is an inorganic compound with a molecular formula of NaOH, and it is a white solid ionic compound consisting of the sodium cation plus and the hydroxide anion OH when dissolved in the solvent. And actually it is mainly found in a pellet forms, which is hygroscopic substance. Once you have to open the container of sodium hydroxide, within a minute it becomes what liquid because it is hygroscopic substance. It can be easily what absorb water or humidity from the environment. Therefore, during weighing sodium hydroxide, be careful to what lead the container immediately after you have to take your sample. And it is very important to measure this sodium hydroxide on the small beaker rather than on the paper, because immediately once you have to keep in the paper, it may be what become liquid there. So when it comes to the indicator phenolphthalein, this phenolphthalein have the molecular formula of C20H40O4 with molar mass of 380.32 gram per mole with melting point of 216, that it can be easily soluble in water. As you see from the structure, you have this phenolphthalein have OH moiety, which can be shown at phenolic class. Therefore, it can be easily soluble in water. So this phenolphthalein is often used as an indicator in acid-base titration. For this application, it turns colorless in acidic solution and pink in a basic solution. As you see in the beaker, in the conical flask, this color is what pink color in a basic media, but it becomes what colorless in acidic medium. It belongs to the class of dye known as phthalate dyes, and the phenolphthalein is slightly soluble in water and usually dissolved in alcohol for use in the experiment. It is weak acid which carries hydrogen ion in a solution slightly. So when you come to the procedure, weigh accurately about 0.4 gram of an ibuprofen tablet. Once you have to crush it by using mortar and a pestle and dissolve in 100 ml of ethanol. Since it is less soluble in water, it can be highly soluble in this ethanol. You have to dissolve in ethanol. Therefore, the resultant solution was titrated with 0.1 molar or normal of sodium hydroxide solution using 2 to 3 drops of phenolphthalein as an indicator, and you have to titrate against sodium hydroxide previously filled in the burette, and you have to continuously or vigorously shake during titration until the pink color can be observed. Once you have to observe the pink color, immediately you have to stop the titration and the burette and record the volume of the volume consumed for the end point, to get the end point. So you have to catch that data as a burette reading data. And finally you have to carry out the blank determination. Here the blank determination means that you have to titrate the pure ethanol or 100 ml of ethanol by using this phenolphthalein indicator, and you have to shake immediately to check the titrate with sodium hydroxide from the burette, and you have to stop once the pink color can be observed. So what is the basic principle here is that this assay determines the content of ibuprofen by acid-base titration, and this ibuprofen or an acidic drug is titrated against sodium hydroxide, which is based using phenolphthalein as an indicator. Once you have to dissolve this ibuprofen tablet with ethanol, and you have to insert phenolphthalein. Here there is no color change because phenolphthalein and acidic media is colorless, and once you have to start titration, it become what? Pink color at the end point. This is a chemical reaction for the titration step. So 1:1 mole ratio of sodium hydroxide and the acid can be react so as to produce what? An acetate salts of sodium as a product. So this is a chemical required for this assay. The first one is, as you see, ethanol. The second one is sodium hydroxide. The third one is your ibuprofen tablet. The fourth one is your phenolphthalein indicator. So you have to use this chemical by using the as a procedure previously we discussed, so as to get what the result you need. So as I mentioned before, during titration, the end point of titration can be obtained when the pink color can be observed. You have to stop the titration and record the burette reading, which can be what? The volume of sodium hydroxide consumed for the titration purpose, for getting what? The end point. So this one is the result or the observation you get. So what type of calculation you have to done after the experiment can be accomplished, or post experiment calculation are here. So what type of calculation and how you can calculate the result and how you report your result. Let me go ahead. Here 70.6 ml, assume this one is, if it is 70.6 ml, so you have to determine the unknown gram of ibuprofen from this titration like this. Ag is unknown gram of ibuprofen equivalent with 70.6 burette reading times 0.09. This 0.09 is the concentration of sodium hydroxide standardized previously in the experiment 1. Since 0.1 molarity is theoretical concentration of sodium hydroxide, this you have to find what? The exact concentration of sodium hydroxide from experiment 1. Assume it is 0.09 times the factor over 1 times 0.11 is simply the mole ratio, therefore times 0.1, that 0.1 is, assume the theoretical concentration of sodium hydroxide, so the result become what? 0.032 gram of ibuprofen. So if this one is the amount of ibuprofen in the titration, you have to calculate the percentage purity as follow. So percentage purity equivalent to the amount of the sample of ibuprofen used over the actual weights first initially we use times 100. Therefore 0.032 over 0.4 times 100 is exactly the percentage purity of your ibuprofen, as it is almost 82% pure. So you have to have this result and go for pharmacopoeia and check whether the percentage purity of the drug that commercially available ibuprofen is in range of this number or not. If it is in range of this number, your experiment is almost error-free of experiment, unless otherwise, if this result is far from that range of the monograph, your experiment is error-prone. Therefore, you have to modify and you have to did the experiment to minimize the error. So from the result, the molarity of sodium hydroxide solution was to be this one. This one is the result you have to obtain from standardization of sodium hydroxide against oxalic acid, and the percentage purity of the given sample of an ibuprofen was found to be 82%. So this one is the result, the way of writing the result for this experiment. So here we have different question for you guys, which is related with our experiment actually, meaning with the general concept or general knowledge of the our experiment, especially ibuprofen, which is mainly concerned with inflammation. So here different question are there. This question, as I mentioned before, can be related with anti-inflammation, and let me start the question. Question number 1 says that which hormone is the major contributor to the symptom of inflammation? A. Histamine, B. Serotonin, C. Bradykinin, D. Leukotrienes. C. So as you see, this hormone, which is a major contributor for inflammation symptom, is bradykinin. So the answer must be what? C. Question number 2, which of the following promotes edema? So the hormone which is associated with edema is, as you know, prostaglandin. So prostaglandin is the hormone that associated with or promotes what? Edema. So this question number 3 says that which hormone is a major contributor for pain during inflammation reaction? This also the same with the actually almost similar with the first question. Here also what? Bradykinin is what the answer for this question, and you have to read the remaining enzyme hormones and their role. When you come to here, which hormone is a major contributor to chemotaxis while inflammation reaction in our body? So histamine, serotonin, prostaglandin, and the leukotriene are there. This prostaglandin also, again, the correct answer for this question. So this prostaglandin can be made from, you know, that from the carbon 20 fatty acid in cyclic form, having what? The pentagonal rings, yes, the penta ring in their structure, which makes it different from leukotriene, because leukotriene have hexacyclic with one carbon can be substituted to oxygen. So the hormone that contributes for chemotaxis while inflammation reaction is prostaglandin. So these all are the questions associated with inflammation. So you have to read this hormone, the effects, and their advantage for our body. So having this concept is enough for today, and to get more video on this course, you have to subscribe the channel, and don't forget to share the link, and you have to write the comment on the comment section of the channel so as to improve something for the next, and until we meet for the next tutorial video, I will thank you very much for your being attention and following until the end of this video.